Good morning, students. So welcome back. So last time we have studied about squares and square roots. We have solved the examples based on it. I hope you have understood that all examples and you have solved the remaining examples. So today we are going to start with the new topic, that is vulgar fractions and decimal fractions. So what are vulgar fractions? So when rational numbers are expressed as ratios in the form of numerator and denominator, then that are called as vulgar fractions. Now vulgar fractions, they are basically of two types: proper fractions and improper fractions. This all you have studied. This is just a sort of revision. Now what are proper fractions? Oh yes, when numerator is smaller than the denominator, then the fraction is called as proper fraction. For example, 2 upon 7. So here numerator is smaller than the denominator. So that type of fractions, they are called as proper fractions. Then improper fractions. So what are improper fractions? When denominator is smaller than the numerator, or numerator is greater than the denominator, then that fraction is called as improper fraction. For example, 5 upon 2. And improper fractions can be expressed as mixed fractions. For example, this fraction, improper fraction, I can express it as mixed fraction. 2 2s are 4. What is the remainder? 1. That 1 comes as the numerator, and this divisor, it comes as the denominator. So this is 2 integers 1 upon 2. How we read it? 2 integers 1 upon 2. Now we can convert that mix to improper. How? 2 2s are 4, 4 plus 1 5. So 5 upon 2. You know that. Okay. Now comparisons of vulgar fractions. Okay, now you know that as these fractions, they have got numerator and denominator is any non-zero integer, so they all are rational numbers. The definition itself has said rational numbers expressed as ratios, okay, which contains the numerator and denominator, they are called as vulgar fractions. Now, so comparison. Now see, when the denominators are same, for example, 1 upon 7, 5 upon 7, 3 upon 7, it is easy to compare. Am I right? When denominators are same. How do we compare them? See the numerators. Greater the numerator, greater is the fraction. Smaller the numerator, smaller is the fraction. So here 5 upon 7 is the greatest, 1 upon 7 is smallest. Okay, now this is easy. Then, next type. Suppose when all the numerators are same, then what? For example, 2 upon 3, 2 upon 5, 2 upon 7. Now here numerator is same, but the denominators are different. Then in that case, the fraction with the greatest denominator is the smallest. So which has got the greatest denominator? Yes, 2 upon 7. So it is the smallest. So then which is the greatest? 2 upon 3. It is because the denominator is smallest there. Okay, so when numerators are same, then see the denominators. Denominators are different. So see the denominators. Greater denominator, smaller is the fraction. Smaller denominator, greater is the fraction. Okay, now this is another type. Then one more type. That suppose there is a common difference between the numerator and the denominator, and the numerator is smaller than the denominator. For example, 2 upon 5, 4 upon 7, 7 upon 10. See what is the difference? 2 plus 3, 5. So difference is of 3. Then 4 plus 3, 7. Difference is of 3. 7 plus 3, 10. Difference is of 3. So when there is common difference between the numerator and the denominator, and numerator is smaller than the denominator. So in that case, the fraction with the greatest denominator is the greatest. So here 7 upon 10 is the greatest, while which will be the smallest? The fraction with the smallest denominator will be the smallest. Do you get it? Okay, so these are the three ways. And in case other than these are the fractions and we don't know these all methods, what to do? Simple thing, divide numerator and denominator of all the fractions and compare them. That is the best way to do. We know the tables, we can do it orally. We need to go till 2 decimal points. In rare case, you need to go for 3 or 4 decimal points. Otherwise, in 2 decimal points, you can decide which one is smaller and which one is the greatest. That is the simplest way. Okay, so we'll see that while solving the examples. I'll come to that. Okay, now next. Now see the next type of example. 1 upon 1 into 2 plus 2, or 1 upon 2 into 3 plus 1 upon 3 into 4 plus 1 upon 4 into 5 plus ... plus 1 upon 27 into 28. So such types of examples, see the type of the examples. Okay, so such types of examples, see the last denominator. It is 27 into 28. So that comes as the answer. It gets simplified to 27 upon 28. Okay, so please remember that. This is a different type of example. Okay, now next we will see decimal fractions. Now what are decimal fractions? That is the fractions whose denominator is 10, 100, 1000, 10,000, 10 or 10 times multiples of 10. If the denominator is like that, then the fractions are said to be decimal fractions. Now, in decimal fractions, when you multiply the decimal fraction by 10, 100, 1000 and so on, the decimal point gets shift towards right hand side. If I multiply by 10, it will shift towards right hand side by 1 digit. If I multiply by 100, it will shift towards right hand side by 2 digits. If I multiply by 1000, it should shift towards right hand side by 3 digits and so on. So number of zeros, see 1 0, it shifts towards right hand side by 1 digit. 2 zeros, 2 digits, shift towards right hand side, and 3 zeros, it shifts towards right hand side by 3 zeros when you multiply. Okay, 3 digits. Okay, now similarly, if I divide the decimal fraction by 10, 100, 1000, then what will happen? So the decimal point will get shifted towards left hand side. If I divide by 10, it will shift towards left hand side by 1 digit. If I divide by 100, it will get shifted towards left hand side by 2 digits. And if I divide by 1000, it will get shifted towards left hand side by 3 digits. Let us see that. Okay, so for example, I have got 3.025, and if I multiply by 100. So if I multiply by 100, so how many zeros? 2 zeros. So decimal point should get shifted towards right hand side by how many digits? Yes, 2 digits. So 1, 2. So the decimal point will come here. So straight away, my answer will be 302.5. Decimal point got shifted by 2 digits towards right hand side. Do you understand? And suppose if I divide 3.025, if I divide by 100, so now what will happen? So as I have said, if I divide, decimal points get shift towards left hand side. By how many digits? 2 digits here. Why? 1, 2. So it will get shifted towards left hand side by 2 digits. But here I have got only 1 digit. So what should be the other? Yes, obviously it has to be 0. Okay, so it will be 0.03025. Okay, you can check it. Where the decimal point it was here. Now I am dividing by 100, so it should shift towards left hand side by how many digits? 2 digits. So come on, 1, 2, 1, 2. Okay, so it comes after 2 digits. So we are right. Okay, so this is about division. Then one more thing. If I have got like this, suppose 2.25. Again it is related to division, and I have got 1.5. Okay. अभी क्या करेंगे? तो simple thing, remove the decimal points and then divide. So how to remove this? Simple thing. See here, write this as 225. Okay, and this as 15. Now give your multiplication sign. See here, 0.25. So how many digits after decimal point? 2 digits. So that many zeros should be written in the denominator place. So here, that many zeros and 1. Of course, 1 has to be there. Otherwise, you will add only 0. So the example will become 0. It's of no use. Right? So 100. 2 digits, so 100 in the denominator. अभी इसका भी हमने डेसिमल पॉइंट निकाला है, तो इसका किधर जाएगा? ऊपर जाएगा. Okay. Now, so how many digits after decimal point? 1. So you should be multiplying here by 10. Do you understand? Now it becomes easy. 1 0 gets cancelled. Okay. Now I know 15 ones are 15. 15 ones are 15. Remember 7. 75. 15 5s are 75. So क्या हो गया? I got 15 upon 10. Now 15 upon 10 means again 1.5, because how I got? In the denominator 10 is there. So decimal point should be shifting towards left hand side. By how many digits? 1 digit. So 1.5 here, right? So here the decimal point will come. Do you understand? Now if I am multiplying, so multiplying is simple. Remove the decimal points, multiply, and then give the decimal point. For example, I have got 1.3 into 1.2 and I have to multiply. तो हम लोग क्या करेंगे? See here, I am showing you vertical multiplication, right? Now, forget about the decimal points. We'll think it afterwards. First we'll multiply. Now I know the table of 12. I know the table of 13 also. Okay, so 12 3s are 36. 3 carry on. 12 ones are 12. 12 plus 3, 15. Am I right? Now, count how many digits are there after decimal point. So this is 1 and this is 2. Total 2. 1, 2, 1, 2. So decimal point should be after 2 digits from right hand side towards left hand side. So 1, 2, 1, 2. Okay, so it will be 1.56. Do you get it? Okay, so in this way, while you are multiplying, okay, don't forget that. Then now we will go for addition and subtraction of decimal fractions. Now, my dear friends, when you are adding or subtracting, the simple basic you follow, that is, place the decimal point one below the other, then you will never make mistake. Forget about the rest of the digits. Place decimal point below decimal point while subtracting or addition. Both are same. It doesn't matter. The only thing is you have to do different operation. In one addition and in the other subtraction, it may be. But the thing, basic what I have to follow is place decimal point below decimal point. I'll show you. For example, suppose I have got 23.015, okay, plus 2.32. Now how to place this? So first what I will do, 23.015. Then what I will see the decimal point. Place that decimal point below decimal point. So 2 point, okay, 3, 2. Forget about this. There is nothing here means 0 and there is nothing here means 0. I am going to add. So decimal point below decimal point. Don't forget that basic, then you will not make mistake. Otherwise what students they do, you know, they do it like this. 2 plus 2 4, 3 plus 3 6 and then they get a wrong answer. And in scholarship, they give that option also. And so you feel, oh my God, I have got it. But when you come out and when you are discussed with your friend, oh my God, I have lost my easy 2 marks. Right? Because I have made that mess of it. Why? Because I have not placed the decimal point below decimal point. Okay? So now, 5 plus 0, 5. 2 plus 1, 3. 3 plus 0, 3. Decimal point. 3 plus 2, 5. And 2 plus 0, 2. So 25.335. That is the right answer. Okay? Same way for subtraction. Follow the basic. Place decimal point below decimal point. You understand? Okay. Now, dear students, let's go for solving the examples. Now see this example. Again, this is one of the different type of example. 1 upon 48 into 100 plus 1 upon 100 into 52 minus 1 upon 52 into 48. So what you are supposed to do? You will go for equalization of the digits. Denominators, not digits, denominator. So here I will be multiplying by 52. Am I right? So this will become like this. 52 upon 48 into 100 into 52. See if you understand. This I am going to multiply by 48. So 48 upon 100 into 52 into 48. And minus. Here what is not there? 100. So 100 upon 52 into 48 into 100. Now see the denominator. 48, 100, 52. 48, 100, 52, 48. 52, 48, 100. All are equal? Yes, they are equal. Now see 52 plus 48. How much it is? 100. And 100 minus 100? 0. So if 0 upon anything, the answer is always going to be 0. Okay? So answer is always going to be 0. So this is the basic of it. 1 upon A into B plus 1 upon B into C minus 1 upon C into A. It should be always equal to 0 if A plus C is equal to B, not 0. A plus C is equal to B. A plus C is equal to B. What is A? 48. What is C? 52. 48 plus 52? 100. And what is B? 100. So A plus C, if it is equal to B, then your answer is always going to be 0. Okay? So now let us move to the exercise 9.1. So first example, if A is equal to B is equal to C is equal to D, then find the greatest of the following fractions. So first A upon 5, second B upon 7, third C upon 3, and fourth D upon 2. Now keep this in mind. It is given that A is equal to B is equal to C is equal to D. And all these A, B, C and D, they are what? Numerators. That means all the numerators are equal. Now when the numerator is equal, to find the greatest fraction, I want to find the greatest fraction. So when will be the greatest fraction? When the denominator will be the, yes, obviously, denominator will be smallest. Now which is the smallest one? Option D. What it is? 2. So correct option is option D. Okay. So option 4. Okay. So option 4, that is D upon 2, is the right answer. Okay. So smaller the denominator, greatest is the fraction. When all numerators are equal. That is the clue here. Okay. So now let's move to the second example. Now see, if 5 upon 7 plus 3 upon 7 into 14 upon 24 is equal to x, then what is x? You need to find out value of x. Keep this in mind, dear students. Don't forget the basics. We forget the basics and we make the mistakes, and then we find, oh no, maths is difficult. Now what is the basic here? There are two types of operation, multiplication and addition. So which should be done first? That is the basic. So you might have studied in 5th and 6th then that when multiplication, addition, division and subtraction, all 4 operations are there at a time, then first preference should be always given to multiplication and division. So here I have got positive plus and multiplication. So my first preference should be for multiplication. That is the basic. Don't add this first. First multiply. Go for multiplication. So you underline here if you don't know. Now, one more thing. Now here there is multiplication sign, so I can cancel also. Okay, so 7 ones are 7, 7 twos are 14, 3 ones are 3, 3 eights are 24, right? And 2 ones are 2, 2 fours are 8. So क्या रह गया? 5 upon 7 plus 1 upon 4. देखा? So that is equal to x. Now what you do? Go for cross multiplication. Can't help, because these are not multiples of each other. Okay, so multiply this by 4 and multiply this by 7. So 4 fives are 20. Now direct I am going. 7 fours are 28. I believe you know this all. So 7 ones are 7 and 7 fours are 28. That is equal to x. Now 20 plus 7. Oh yes, 27 upon 28. That is equal to x. So option number again 4. Option 4 is the right answer. Okay, so now next example. Now see third example. When Ravina read 3/4 part and 17 pages of a Marathi book, 28 pages were left to be read. When Kajal read 3/5 part and 20 pages of a history book, 26 pages were left to be read. How many more pages were there in Ravina's book than the number of pages in the book that Kajal had? Okay, now do we know the total number of pages in both of the books? We don't know. So we'll assume that to be x or y. Okay, so first let us go for Ravina. Okay, so let us find for Ravina's book. Now Ravina read 3/4 part, means 3 upon 4 into x. Total number of pages x. Then how many pages were left? 17 pages. So plus 17. Sorry, not left, she read 3/4 part and 17 pages. So she read 17 pages plus 17. And how many pages were left? 28 pages. Okay, so plus 28. Okay, so plus 28. Now that total is equivalent to total number of pages. I hope you have understood. Okay, now so 3x upon 4 plus 7 plus 8, 15, 1, 2 plus 1, 3 plus 1, 4, so 45. That is equal to x. Now bring this to this side, it will become minus, yes. So 45 equals to x minus 3x upon 4. Go for equalization. Okay, so 45 equals to 4x minus 3x upon 4. Okay, now so 4x minus 3x, 1x. So bring this 4 to this side, it will be in multiplication. So 45 into 4, that is equal to x. So therefore x is equal to 5 4s are 20, 2 carry on, 4 4s are 16 plus 2, 18. So 180 pages. 4 5s are 20, 2 carry on, 4 4s are 16 plus 2, 18. Okay, now let's go for Kajal. Now Kajal read 3/5 part of the book. So I call it as 3 upon 5 into y and 20 pages of that. So how many pages were left? 26 pages were left. So plus 26. So that total is equivalent to y. Okay. So that comes out to be y. Total number of pages. Okay. So now this becomes 3y upon 5 plus this is 46. That is equal to y. Bring this to this side. So it becomes subtraction. So therefore 46 equals to y minus 3y upon 5. So therefore 46 equals to 5y minus 3y upon 5. So therefore 46 equals to 5y, that is 5y minus 3y, that is 2y upon 5. So bring this to this side. So it will 5 will go in multiplication and this 2 will go in division. So therefore 46 into 5 upon 2, that is equal to y. So 2 1s are 2 23s are, and 23 5s are 115 exactly. Now so Kajal read 115 pages. Kajal's book has actually 115 pages total. Now who has more number of pages? So more number of pages. Definitely Ravina has, that's what they have said. So what he will do? Subtraction. So 180 minus 115. So 10 minus 5, 5. 7 minus 1, 6. So how many pages? 65 pages. Okay. So option number, yes, option number 1. So option 1 is the right answer. Okay. So that is the correct answer. So let's move to the fourth example. Now see the fourth example, 6.75 into 5.5 plus 5.5 into 3.25 is equal to how much? So what you will do? You will multiply this, then you will multiply this, then you will add and then get the answer. Don't do that. See the example carefully. Something is common. And which property? I am going to tell that property. Name of that, you guess it. Okay. Now, see here, 5.5 is common. So take out that 5.5 and left is what? 6.75 plus 3.25. Now, what is this property called? I am just writing that. A into B plus A into C. That is equal to A into bracket B plus C. You guess what this called? This year you have studied this in topic number 1, if you remember. Okay, so name that what it is called. I have given you. Okay, now see what happens. 5.5 into, add this, it becomes easy. 5 plus 5, 10, 1 carry on. 7 plus 2, 9 plus 1, 10, 1 carry on. Decimal point is there. Give the decimal point. 6 plus 3, 9 plus 1, 10. देखो कितना easy हो गया. So 10.0. 10.0 means 10 only. Now 10 into 5.5. तो हमने तो पढ़ा है when I multiply by 10, decimal point should shift towards right hand side by 1 digit. Right? So this decimal point will come here. And so the number will become, oh yes, 55. And so option number again is 1. So option 1. Okay. So let's move to the fifth example now. Now see fifth example. Which of the following fractions has value between the fractions 1/3 and 1/2? So these are the two fractions. And you have to find which of these have got value between these. So simple thing. Equalize the denominators. Now you can see here all are 12. Okay. So first what we will do, we will make them as 12 because it is easy. Why? Because 3 how many are 12 and 2 how many are 12 accordingly. So 1/3 I can write this as 1 into 4 upon 3 into 4. So that is 4/12. Am I right? Okay. And 1/2. So 2 how many are 12? 6 are. So 1 into 6 upon 2 into 6. So 6/12. Now, which of them have got value between these two? So 4/12, 6/12. 9/12 bigger than that. 7/12 bigger than that. 5/12. Oh yes, 5/12 is in between these two. So that is what the answer is. Option number 3. Do you get it? Okay. So let's move to the next example. Now, sixth one. 3 integers 1/10 into 3/10 plus 1 integer 2/5 divided by 2. Keep this in mind. When multiplication, division and addition operations are there. So first preference should be given to multiplication and division. And that too from left hand side towards right hand side. So which one comes first? Multiplication. You can do multiplication. Again, here I can do division also. But before that, this is a mixed fraction. And this is also mixed fraction. I can convert them into improper fraction. So 10 3s are 30 plus 1. Yes. 31/10 into 3/10 plus 5 1s are 5. 5 plus 2. 5 plus 2, 7. So 7 upon 5. Now this division I can convert it into multiplication, and then that multiplication, when it becomes multiplication, inverse of this has to be taken. So it becomes 1 upon 20. Okay, so it becomes like this. Okay, now both are multiplication, so you can do that. 31 3s are 93 upon 10 10 is 100 plus 7 on the 7, 25 is 100. Oh my God, denominators are same, so we can add the numerator. So 93 plus 7, 100. So 100 upon 100, that is equal to 1. Okay, so option number 2. Option 2 is the right answer. Okay, so let's move to the 7th example. Now see 7th example. Which of the following numbers is greater than 5 upon 7 but smaller than 11 upon 14? Okay, now keep this in mind. No doubt 14 is multiple of 7. But here I have got here 7, I have got 21 and 7 and 21. So it becomes troublesome. So what to do? Simple thing, convert them into decimal forms and then it becomes easy. So 5 upon 7, what it can be? 5 upon 7, I can write this as, okay, 0 point. So it becomes 50. 7 7s are 49, right? Remember 1. So 10. 7 1s are 7. Stop there. Stop there. It's sufficient. Then 11 upon 14. What I can write? 0 point. 110. So 14 8s are how much? 14 8s are 112. 14 7s are 98. Right? 14 7s are 98. Or you can check it like this. Okay, 110. 14 8s are how much it becomes? 112. So I don't want that. 14 7s are 98. Kitna remainder hai? 2 plus 10. So 12. 12 is the remainder. So it becomes 120. So 14 8s are. Okay. So 14 8s are how much? 112. Bas ho gaya. 0.78. तो हमें इन दोनों के बीच का नंबर चाहिए. So I want to find decimal forms of this. Okay. Now this will become 0. So 60. 7 8s are 56. I don't want because this is 0.7, 0.7. This is 0.8. Cancelled. See it. Okay. Then 0.160. 21, how many is a 160? 21 6 are 126. 21 7s are how much? 167. Right? So 21 6 are 126. 21 7s are 167. So 21 6 are. So 0.6. तो ये दोनों से भी smaller है. It's of no use. Okay. 21 7s are 147. Sorry. So 21 7s are 147. So 0.7. Yes, we can use. 21 7s are 147. So 160, 147. So 13. 147 plus 3, 150 plus 10. So 13. 13 yani 130. So 21 6 are. Oh my God. You can see this is in between. We'll check for others also. This is 0.40. So 40 हो गया तो कितना हो गया? 7 5s are 35. 50. Not necessary. It is too smaller. Then let us check this. 0.190. So 190 यानी 21 9s are 189. है ना? 21 9s are 189. So too much greater. So this is also wrong. This is also wrong. This is the correct option. This is wrong. Okay. So option number 2. Option 2. Okay. Now let's move to the today's last example. That is 8th example. Now 8th example. If 24 is added to 4 upon 7th of 3 upon 4th of a number, the result is the same number. What is that number? Do we know that number? We don't know. So let the number be x. Okay, so let number be x. So what it says, 24 is added to 4 upon 7 of 3 upon 4 of a number. A number means x. Okay, so we are adding what? 24, and you get the same number. Okay, so that is same number. Now we will put that in equation. So we have assumed that the number be x. So 4 upon 7 of means multiplication. 3 upon 4 of means multiplication. Number means x plus 24. That is equal to x. Okay, now see here. 4 1 4. So क्या रह गया? 3 upon 7x plus 24. That is equal to x. So therefore, bring this to this side. It becomes subtraction. X minus 3 upon 7x. Go for equalization. So what happens? 24 is equal to 7x minus 3x upon 7. So 7x minus 3x, obviously 4x. So therefore, 24 is equal to 4x upon 7. Now, bring this 7 to this side, so it will be in multiplication. Bring this 4 to this side, it will be in division. Okay, so therefore, 24 into 7 upon 4, that is equal to x. So 4 1 the 4, 4 6 are 24, and 7 6 are, yes, 42. Okay, so 7 6 are 42. So what is that number? 42. So option number 1. Okay, so option 1 is the right answer. So dear students, I have solved exercise 9.1, all examples. So go through all these examples. In the next video, we will solve some examples of 9.2 and 9.3, and remaining examples you will be solving them as homework. Even if you try them today also, will do, doesn't matter, and then you can go through what I tell you. Okay, so today we will stop here, and I hope you will take down all this in your notebook, and if there is any doubt, you will definitely call me. Okay, so let's stop here, and thank you. Let us meet in next week. Goodbye.